So, welcome to all. Today, we are going to do some more MCQ type question related to the control system. Let me open that file. So, what we are going to do today, some more questions related to the control system, MCQ type questions. Okay, so let us start. Now, this question will be related to the so-called steady state error. Okay, so the question is that a given transfer function is there. Okay, and you have been given 4 options and you have to find out which statement is correct. Now, again, you have to use the mind here that which option is correct, and then after choosing the correct, you may be given 4 options that the following options are correct. Okay, so let us start. Suppose the open loop transfer function of a unity feedback system is given like this. Okay, so transfer function is given as dictated 5 upon 1 plus 0.1 s, okay, upon s plus 5s and 1 plus 20s. So, in this question, you have been given this transfer function. Mind it, it is this is an open loop transfer function. Okay, so the question given is that it is an open loop transfer function. Okay, so what do you mean by open loop transfer function? Also, it is given that it has a unity feedback system. So it is representing basically GS, HS, and HS is 1. Therefore, it is completely GS. It is not closed loop transfer function. Mind it. It is simply an open loop transfer function GS, HS. Okay, and HS is being given unity. Therefore, it is simply GS. So you have been given this transfer function, and now 3 statements are given related to this. The first statement is that the steady state error for a step input of magnitude 10 is equal to 0. Okay, so when you apply a step input, the steady state error step input of 10 magnitude. Okay, so it is 10, not unity. The error comes out to be 0. Steady state error comes out to first statement. Okay, second statement is given. Okay, the steady state error for a ramp input of magnitude 10. Again, a ramp input is being applied of magnitude 10. Then the steady state error ESS is given as 2. Okay. And the third statement related to this given as the steady state error for an acceleration input of magnitude 10. Okay. So now acceleration input is being applied. ESS is given as how much? Infinity. Okay. So we have to find out. Now, these are 3 statements given regarding to this open loop transfer function. And now you will be given option A, B, C, D. What is A? A option is that only 1 and 2 are correct. B option is that only 1 and 3 is correct. C option is given. Okay. Only 2 and 3 are correct. And D I am writing here because I don't have the space. So I am writing here. D is given. Both 1, 2 and 3 are correct. 1, 2, 3 are correct. Okay. Now you have to choose from this A, B, C, D which statement is correct regarding these 3 statements often for an open loop transfer function. So you know that first of all, whenever a question of steady state error is there, we talk about the type of the system. Okay. we have to find out what is the type of the system. And how will you define type of the system? Again, I am reiterating, type of the system is defined as the number of the poles for an open loop transfer function at the origin. So how many poles are locating at the origin for an open loop transfer function? Okay, accordingly, we say that what is the type of the system. So here you can see S is there, okay, and this S is clearly indicating that there is a one pole is lying at the origin for open loop transfer function. So this type is 1. So it is very clear the type of this system is 1. Now, if you remember my slides, okay, if you've gone through my slides, then I have told you that whenever there is a type 1 system is there, then what is the value of Kp? Kp is nothing but how much? Limit S tends to 0, GSHS. Okay, so here since 1 upon S term will come, okay, so it will make in fact Kp will make how much? Infinity, and therefore the steady state error will be 0. Okay, so whatever step input you apply, either of 10 magnitude or of 15 magnitude or 20 magnitude, the steady state error will be equal to 0. That means first statement is correct. Now the second statement. The second statement is related to the when and which type of statement? Ramp input is being applied. So you know that for ramp input, Kv, velocity error constant. Now velocity error constant is given how much? Okay, limit S tends to 0 S GS. You all know, or simply GS, because HS is 1. So SS, this S and this S will cancel. So we are left with this. Now you apply S is equal to 0. So this became 0, this became 0, this became 0. So you are left with only what? 5. So KV became 5. But steady state error is how much? If you remember, steady state error is nothing but amplitude A or amplitude A upon the KV. Okay, so amplitude A is 10, KV is 5. So 10 by 5, 2. Oh, it is also correct. First is also correct. Second is also correct. And now let's talk about the steady state error due to ramp input. Now, due to ramp input, you know that we find out Ka. Ka is nothing but S square GSHS. Okay, I am simply writing GS because HS is 1. So when I will put this open loop transfer function GS here, the SS will cancel, and in the numerator we have a S term. In the numerator we will have an S term. Okay, so when I apply limit S tends to 0, okay, so what will happen? This whole will become 0, K will become 0, and therefore your steady state error, which is nothing but amplitude A upon K, amplitude A upon K, and that comes out to V0, so it became infinite. Oh, great. So third is also correct. Okay, so your option D is correct. 1, 2, 3. So you can see through one single question, all concepts related to steady state error has been evaluated by the examiner, and therefore you have to concentrate not only on single formula but all the formula, all the concept, and his D is the correct answer. I think so. It is very clear that how to find out the how to solve such type of MCQ question when steady state error is going. So this is one such question. Okay, let us take another question. Okay, another question. You can be asked a formula based question also. So I think so this is clear or not? If anybody is facing problem, please write in the chat box. Okay, so let us take another question. A question is, a second order control system has a transfer function like this. Now a standard transfer function is being given in the question, that is CS by RS is being given, and it is equal to omega n square upon S square, okay, plus pi eta omega ns plus omega n square. Okay, so now again what happens? Now take, this is a different type of MCQ type question. Two lists have been given, list 1, L1 and list 2. Okay, these have been given. Okay, now what happens? In the list 1, option A is given as rise time. I'm simply writing short form RT. B is given peak time. I'm simply writing PT. C is given peak overshoot PO. And D is given settling time ST. Okay. So these 4 names are given: rise time, peak overshoot, and settling time. In the list 2, we have the formulas. Okay. Now so formulas are given 1, 2, 3, and 4. Okay. What are the formula? The first formula is given pi minus tan inverse bracket under root 1 minus eta square upon eta bracket closed. The second formula is given, oh sorry, upon, there is upon word is also there, and that is omega d. Okay. The second formula I am writing here, it is given pi upon omega d. The third formula I am writing here, it is given e raised to the power minus pi eta upon under root 1 minus eta square. Okay. And the fourth formula is given 4 upon delta omega n. Now these two lists have been given to you. Now what happens? The option, now you will be given the options, and and you have to find out one option which is correct. So you will be given codes. It will be written as codes. So option, right here it is written A, B, C, D, and here is the option: first option, second option, third option, and the fourth option. So the first option is 1, 2, 3, 4. 1, 2, 3, 4. The second option is 3, 4, 1, 2. The third option is 1, 4, 3, 2. And the fourth option is 3, 2, 1, 4. Okay, so what you have to do, you have to do the match the following as you do in the lower classes. You match the things. Okay, so the first is rise time. So what is the formula for the rise time? You among these 4, you have to match that. A matches with which number? 1, 2, 3, or 4. Similarly, peak time, you have to match with the, what is the formula for the peak time? Peak overshoot, you have to match with the formula. Similar, settling time. So you see that, let us start with S, settling time. So settling time is nothing but 4 upon delta omega n. This formula I have already derived it. Another is peak overshoot. Peak overshoot is this: e raised to a minus ps upon 1 minus delta n. And then come the peak time. Peak time is nothing but pi upon omega d, and the rise time is pi minus tan inverse this. So your 1, 2, 3, 4 option, that is the first option, is the correct option. So you can mark it as the answer. So you see, all formulas are given, all terms have been used, and then your ability, aptitude has been tested, that whether you can remember or not. So this is another type of MCQ type question is there. Another question, okay, that is related to the block diagram. Okay, so let's take another question. A block diagram will be given to you, though it may appear to your mind that the block diagrams are generally theoretical questions being asked in written exams, but it is not there. It can be asked in the MCQ type question also. So let us see another question. So a block diagram is given to you like this. This is one. 3 block diagrams are there. This is second, and this is a third one. So arrow sign is very important in the block diagram. If you are missing the arrow sign, then It will not govern you in which direction you have to move. Okay, so you see these are the 4 block diagram. This is C, this is R, R is input, C is the output, this is H, this is again feedback function F, and this is G. So now to solve this, what happens? How to solve it? So you will be asked what will be the it will for the feedback system shown in the figure below, which of the following expresses the input output relationship C by R of the system. Okay, so you have to find out C by R. In other words, you have to find out the closed loop transfer function. Okay, so what you do, then now you look towards this. Okay, this is in a feedback form. Okay, and this is also in a feedback form. Okay, so you will definitely ask, this is negative and this is positive. Okay, so how to do this question? Anybody from your side? So what you will do, that you will first of all take this question, this as an loop. This loop you can take it as a negative feedback system. Okay, so what is the overall transfer function of this? This is nothing but G upon 1 plus GH. G upon 1 plus GH. So now your figure look like this. G upon 1 plus GH. Clear? G upon 1 plus GH. That I have already given you, and you are left with a summing point, and this summing point has a positive feedback, mind it. Positive feedback with value F. And this is your C. So now you have to, this is your R. Okay, so now this is again a feedback, but which type of positive feedback? Now G is what? G is became G upon 1 plus GH. So now you calculate again the formula GS upon 1 plus GS HS. So H is here F, mind it. So it will become how much? If I write G upon 1 plus GH, okay, the overall transfer function, whole divided by 1 plus G upon 1 plus GH into F. I think so it is clear. So sorry, here it will be not minus sign. Please, it will not be plus sign. Oh, everything has lost. Sorry. So I am writing down the overall transfer function C by R is nothing but G upon 1 minus 1 plus GH, okay, 1 minus G upon 1 plus GH into F. Okay, so 1 plus GH will cancel out and you are left with G upon 1 plus GH minus GF. Okay, so you will be given 4 options. So among this option will be the correct. Okay, so you got my point, how to solve it? These questions, these are, I will take now a last question. Okay. Now, question has been asked regarding the order and a type of a system. Okay, order and a type of a question. You have been given what are the order and type of a closed loop system for the plant transfer function GS is equal to this. So you have been given GS plant transfer function, mind it. Okay, and it is given K upon. So you have to understand the question. Please go through the statement which I have iterated in front of you, that it is a plant transfer function. So what? First of all, let me write the question. 1 plus TS. Okay. So you have been given what are the order and type of the system. You have been asked order and type of the system. Please listen carefully. What are the order and the type of the system for the plant transfer function? GS is equal to this much, okay, with unity feedback. So it is very clear that HS is equal to 1. So GS and HS is being given, and now you have to find out the order and type. So you know that order is found by with the help of closed loop transfer function, mind it, and type is being found with the open loop transfer function. Okay, so in the closed loop transfer function, so first of all, let us find out type. Type is found out by open loop transfer function. And what is that open loop transfer function? GS multiplied by HS. So GS is given this much, HS is 1. So GS HS will remain as is. And now you know that to find out the type, we find out how many poles are lying at the origin. How many poles are lying at the origin? So you can see 2 poles are lying at the origin. So it is very clear that type is 2. Type is 2. Now you have to find out the order. For the order, you have to use the formula for the closed loop transfer function, GS upon 1 plus GS HS. So GS is this much, K upon S square plus 1 plus ST upon 1 plus GS HS. Okay, so K upon S square 1 plus ST multiply by HS. HS is unity, so no problem. So this whole denominator will cancel, and you are left with the closed loop transfer function will be K upon S square plus ST plus K. So it is very clear that the highest degree in this closed loop transfer function is 2, hence order will be 2. So type is also 2 and order is also 2. So you will be given 4 options. The first option 2 and 2, the second option 3 and 2, the third option 2 and 0, the fourth option 3 and 0. So it is very clear from our analysis that the order is also 2 and the type is also 2. The first option is correct. I think so. These 3-4 questions are, I think, sufficient. So you practice more questions. In between the holidays also, I will be taking class so that you practice more and more questions related to this. Any doubt? You can write in the chat box. Okay, I can take the chat, your doubt. Kajal cover S3, it will be S3. Oh, sorry. Yes. Kajal cover, you are correct. It will be S3. Yeah, when you open the bracket, it will be S3. Yes. Yes, it is very correct. It will be S3. So type is 2 and order is 3. Let me correct myself. Okay. The order is 3 and type is 2. So B option will be correct. 3 and 2. Very correct. Kajal Kavar, you are correct. Kirti Verma is asking about the midterm about the, okay. So still date, there is no information. So let us wait for the opening of the college. College will open after 21st, because from 13 to 21st, and probably on 22nd it is Sunday. Therefore, it will be going to open on 23rd. So when it opens, then only I can tell you that what will be the dates of the midterm exam. And as far as syllabus is concerned, okay, whatever we complete before the start of the so I don't have any information regarding the electrical timetable. If I will get it, then I will let you know. Don't worry, I am very serious about it. So as soon as I will get it, I will circulate it on the WhatsApp. So no problem is there. Okay. Any more question? Yes. Kajal Kaur, your answer was also correct. So I think so. The question is now clear. Okay. So I am ending the meeting. Okay. So we will meet again. Yes. Notes I will give you. Definitely I will give you. Sorry for the still not given. I will give you.